Thanks, Kevin. Thank you, Kevin. Come on. Can you hear me? Oh? Yes? Okay, great. Well, I'm going to spend a little bit of time talking about the first part of the presentation, talking about how I'm with LSI, and so we view storage and some of the data center problems that we see and we think need to be addressed and solved. But actually, Kevin did a lot of that for me. So I'll go through it very fast just to keep some consistency in our thought process. But I think you'll recognize them probably from your own experience and certainly from Kevin's presentation as well. And then I'll talk a little bit about the main thrust of the conversation is an alternative that Kevin did not talk about, a storage interface, extending SAS into some other functional areas that might be a little more cost effective, but equally performance capable as the solutions that exist now. So this is a slide. I was recently at the Storage Networking World, and so I stole a lot of slides from there. They were very much more knowledgeable people, and this is from IMEX Research about technology, broad technology spectrum, how storage is going. We're moving up and to the right. Many applications feature throughput in terms of bandwidth, megabytes per second. That's the horizontal axis. Other applications feature IOs and the vertical axis. And in our experience, we're seeing a shift from maybe that horizontal migration to the vertical migration. IOs are becoming more important. One of the biggest reasons is the market is being driven by transaction processing and particularly e-commerce. So although these circles don't represent the relative storage volume that we sell, but clearly in our sales, the e-commerce is a big driver. So that's obviously near that vertical axis, makes that very important. Another technology reason for that, or another technology reason driving IOs is virtualization. Because when you take processors and you actually time slice them and shift from one function to another, obviously you randomize the net storage activity. So IOs are becoming more important. This is where Kevin really talked about scaling. Okay, it was one of the issues that existed in his talk, and we see that as basically there being three things. You scale to meet increased demand. Okay. While you're doing that, you want to ensure a high quality of service, and obviously you have to minimize cost. I think he touched on each of those. And this is a very broad system architecture to ensure quality of service, maybe by adding servers in the front end. Maybe you virtualize the servers you have to attain that. You meet demand by scaling the storage bandwidth to access more storage, but you ultimately have to minimize costs. Maybe you incur some data tiering, utilize existing storage, et cetera, in that implementation. One of the things that impressed me the most, or I guess continues to impress me, is the scale of scalability. I found this slide. It's from a website called Data Center Knowledge, and one of its claims is that Oracle has 900,000 servers. Okay, and these are some data points of how many servers other companies have. It absolutely boggles my mind the amount of servers that are out there. And then all these are virtualized. These are the physical servers, right? I was also recently at the Intel Developer Forum a month or so ago in San Francisco, and there was an interesting data point from one of the speakers there that for every 60 smartphones that are sold, a data center has to add a server. Well, we know how many smartphones are being sold, right? So there's a lot more servers going into service. Right? So clearly, with hundreds of thousands, millions of servers, power consumption, we know that. Maybe that's why Google moved to Topeka, I'm not sure. But anyway, power and heat, space, and cost are all critical parameters when you multiply them by millions. Any parameter is going to become very important. The one I highlighted there in blue is connectivity, is where I'm going to come back to eventually in terms of connectivity, is also because it not only scales by the number of servers, but it scales by the connectivity, how many servers connect to how many storage devices. Right? So picking the right connectivity is very important in the overall solution. One of our partners actually had done some market research on those connections, and their market research indicated there were 20 million ports typically being sold per year, okay? And 10% of them are external ports, okay? That is connecting between servers and storage systems, et cetera. And that 1% of those 20 million were actually extended distance, like over 10 meters, between 10 and 25 meters, okay? Not intra-campus sites, but just within a server from this end of the room to that end. So one of the quality of service issues is again from SNW, the rate of growth of server power has grown exponentially much faster recently than storage. Storage has a great growth curve over the long term, but in recent years it's being outrun by storage. By servers, by IOs. It's enabling that user curve, or the other way around. The user curve is driving the need for the server performance. And so many of the presentations that S&W talked about compared servers growth, processor growth specifically in a server, to individual disk drive growth. So being from LSI, I had to say that although that data is true, that's really not what the user experience was, because there are lots of companies, LSI being one of them, that actually aggregates the performance of an individual drive to bring those performance levels closer together. However, that still isn't enough. We are limited by the underlying performance of the storage devices, okay? Even though the LSI RAID controllers and HBAs now are not limited by the storage devices, we cannot fulfill the requirements of these new I/O-driven applications. One of the reasons is this little hierarchy of latency, okay? Many processes take different times to yield their results, right? And some are very fast, like the caching activity in the processor, fractions of nanoseconds. Many are very slow, like with the bottom one there is to send a packet from California to the Netherlands. It takes milliseconds, right? But if you remember that application chart, it was talking about hundreds of thousands of IOs. Right? And so obviously where you move in this chart, what things you address, are going to affect how effective you can do that. For example, simply increasing an L1 cache in a processor wouldn't really change the transaction process time very much. If you took it away, it would only make 1/10 of a nanosecond difference, right? So where are the key elements, right? And in the storage area, they're in the middle. The activity that LSI engages in is taking individual disk drives that are on the order of milliseconds, turning them into microseconds, giving us tens of thousands, maybe 100,000 transactions per second out of devices that are individually basically capable of 100 IOs per second. Okay. All of that is an attempt to ensure a quality of service to the server. Of course, there are other technology advances, and that underlying need, as I'm sure you all know, for faster storage is today being addressed by SSDs. And this is just a depiction that I stole from IMEX research of relative number of, or relative performance, how many IOs can be served. Here it's also consistent in this presentation with number of users, the horizontal axis, with different technologies. When these curves break up, it's when they upward physically, those curves, that's the saturation level of that technology. So you can see 14 hard drives, relatively inexpensive, but can only serve maybe 1,000 IOPS. If you had a bunch of the techniques that have been developed over the time to take traditional disk drives and make them faster, like short stroking and fast access times and high RPMs, very costly, okay? And it takes an order of magnitude more drives to get an order of magnitude more users. And then there are hybrid drives. I don't know if any of you are engaged in that activity or not, where actually the drive manufacturers put some flash memory on the disk drives themselves, attempt to increase the cache of the drive. And the last one is actually just using a fully SSD implemented solution. All of these have slightly different performance enhancing characteristics, but in the gross level, they're all moving to the right. They're enabling more users access to a fixed amount of storage. There's another dynamic or activity that we actually think is more pragmatic, and that's the notion of storing, of tiering storage. Okay, many of the applications, particularly in that high e-commerce area, and in social networking is another famous example that we use, where tiering makes a great deal of sense. And one classic example is, if I'm not on Facebook, I don't care about the access time to my data. It can go to 0 or go to infinite in terms of access time, and it's okay with me. Okay? But once I'm logged on, now I have a very high expectation, right? And so many applications are like that. Okay? I don't think there are any database applications where access is strictly uniform. But the bigger the break, the more opportunity there is for smart intervention on the storage subsystem. And so we think there's a place where we can contribute and where the industry can make a contribution to performance as well. So what I'd like to do, so that's it on the background of storage and broad trends and things to talk about. Now I'd like to talk about SAS. In fact, I'd like to just start out by saying we think SAS is a good alternative to Fibre Channel, okay, for any SMB application for storage. It's functionally equivalent, but a lot less expensive, and that's the bottom line, okay? But that's a pretty bold statement, and a lot of people will challenge it, and we challenged it ourselves. And there are applications where clearly it won't be broadly, where it won't apply. But there are broad applications where it will. And so these are some of the reasons we think that it does make sense, where it does make sense to talk about SAS as an alternative. First of all, as using SAS has the characteristic, as does Fibre Channel, of being a storage interface and a host interface. Unfortunately, Fibre Channel priced itself out of the storage interface area already. Okay, so there's sort of a trend already underway in that regard. We'll show, hopefully in the next few slides, that it has SAS has the least impact on the market. The way the market is moving, SAS is actually better positioned to deal with high IOPS than Fibre Channel. Okay. Obviously, I already mentioned the cost factor. Has greater bandwidth, at least as practically implemented. Probably where 6 gig SAS is the nomenclature we use, but every 6 gig external connection that we talk about today is really 4 lanes, so it's really 24 gigabits. So the thing you plug into a SAS external port is 24 gigabits per second of bandwidth compared to 4 or 8 of Fibre Channel. And we have some additional features that have been traditional roadblocks in the SAS world. One is a SAS switch, a functional area that was not previously addressed with the SAS infrastructure. And another is the cable length area, okay, that was previously not addressed in SAS. And then the last, SAS also has a future roadmap. It goes on to 12 and beyond gigabytes. That's, you can see that. I'm not going to talk about that, but that's at SCSI, SCSI TA, SCSI Trade Association.org website. So I mentioned that we weren't sure we believed that proposition either, so we went out to test it, okay? And we hired a third-party firm to do some work for us, and the company was Demartech. You may have heard of them. They do benchmarking for lots of companies. And we did, this is a high-level structure of the test. We basically had a server, a storage system that was capable of Fibre Channel, SAS, and iSCSI implementation. And we tested those 4 interfaces, 1 gig and 10 gig iSCSI. And we tested them in a switched and a direct connect to see what the impacts of switching were. And we tested them for a range of block sizes. Testing them itself has its own characteristics. A few years ago, if you said tested a storage subsystem, I think most of the people that you talked about would assume that was iometer. And much of the industry still uses iometer to test storage subsystems. But we think that market trend, the enabler, the thing that communicates more information, is really about the IOs. Probably isn't as readily visible in iometer as it is in some other test tools. And the one we chose was one that was focused on the, I mentioned e-commerce as the prototypical, the killer app for IOPS in the data center. Almost all those applications run on some version of SQL. And Microsoft's test measure of SQL is a program called SQL IO. Okay? So we chose that. We asked Demartech to use that tool to actually measure the efficiency, the appropriateness of the SAS interface all the interfaces to storage. That program presents the data a little differently than we're used to looking at it. It actually presents data in terms of latency, okay, and a histogram of how long it takes typically for a system to respond. And it buckets those responses into milliseconds, and then it gives you a histogram of how many were in each of the buckets. So the goal here, a perfect system or a very high-end system with all the response, you have 100% in the first bucket on the left between 0 and 1 millisecond. That would be a great storage subsystem. And you can see in general, that's the way these curves bunch up there, and they do move that direction, with the exception of one. It's not too surprising that the yellow bars here, they may be hard to view from the back, but those are 1 gig iSCSIs, and they have a distribution that has a long tail. Okay, and some of those performance take up to 20 milliseconds. Not too surprising, I think, from most of us in the room, right? 1 gig iSCSI is not a high-performance storage interface. So I'm not going to spend a lot of time talking about 1 gig iSCSI anymore. Okay, but this is the detail for the direct connection of the other three. And in the first two columns there are the 0 and 1 millisecond buckets. And you can see it's summarized in the next to the last column there for 6 gig SAS, 8 gig fiber channel, and 10 gig iSCSI. And contrary to the names, 6, 8, and 10, the fastest, the one that has the highest percentage of accesses in the shortest time is 6 gig SAS. Okay? Now, they're not substantially different. The difference between 6 gig SAS and 8 gig fiber channel is the difference between 97.38% and 97.21%. I'd submit that's really no difference. Okay? So it's saying, really, these interfaces are the same, performance-wise. Okay? And if you go a little bit further out, the difference actually narrows, okay, to 2 milliseconds. 2 milliseconds is 5,000 IOs, right? First order for a single user, some assumptions. Right? So essentially, all these interfaces have the same latency response. I mentioned the other thing we wanted to test was block size. And so this is a variation, again, of all 4 interfaces. Block size, the bars on the left are the read performance. The bars on the right are the write performance. Traditional storage systems, writing is a little harder than reading. No big deal there. And in all those cases, the blue bar is the SAS. In all those cases, the SAS outperforms, that is, has higher IOPS than fiber channel, with one exception. Okay? So on 4K data blocks in this test, fiber channel still outperformed the SAS. We think that has to do with the optimization of the HBAs that were used in the test. Okay? We're pretty sure if we polished hard, we'd be able to get that bar reversed into SAS as well. But those were the test results. And all those are, again, are random IOs, the way a virtualized server system would look at. The other question that we want to talk about is switching versus non-switching. So these are the two characteristics for all four interface types. The one on the left are the direct access, the one on the right are the switched. I'm sure here it's very hard to tell the difference, so I replicated the chart from before. That's the first line is the direct, same numbers as you saw before, but right below it are the switched numbers. And you can see there's, again, not a very significant difference between switching and direct connect. All the switches of these technologies are low latency switches as well. Now there's one exception. Whoops. Well, there was one exception to that data point. You can see actually in the 10 gig iSCSI in the far right, switching is actually 0.04% better than non-switching. It's probably a questionable result. Putting an extra device in the system should add latency, but we'll take that to be within the error of the test. Okay. So I wanted to talk a little bit about, so we've sort of proven that latency-wise, the premise of actually the talk where I started was that the latencies are basically equivalent. I'm done with my talk. Okay, but I want to add a couple things. Okay, so one was there are benefits to adding a SAS switch. Okay, this new technology, partly because it's newer, actually has a higher bandwidth than fiber channel and iSCSI. Okay, again, that's easy. That's the easiest comparison. That's the thing I just mentioned: 24 gigabits versus 8. Okay, it's 3 times fast, 3 times greater bandwidth. Okay. The efficiency is 9 times lower power per port, okay? And if you take the bandwidth and the price, the value is better for SAS as well, and I think that's common experience. This value doesn't include the cost of cables, which we all know fiber channel cables are very expensive. Right? So it's worth taking a look at. If your application requires switching, SAS isn't a barrier, it's a benefit, okay? And then the last thing was distance. A traditional limitation of SAS was that SAS was considered to be an in-the-rack interface. Well, it can go outside the rack, okay? We talked about the statistics, 1%, that's 200,000 ports need connection greater than 10 meters, okay? Well, there are active cables. Actually, LSI helped pioneer the standard, SAS 2.1, which includes active SAS cables. They will be part of standard practice in 12 gig SAS, but they enable distances. The cost per foot is no greater than 2 meter SAS for 20 meter SAS. And a hidden benefit is that the cable sizes actually get smaller. And actually we have some white papers and things we can talk about another time where actually because the cable is controlled, the impedance is controlled, the actual eye diagram is actually bigger for active cables than for passive cables of shorter length. So actually higher reliability in that regard. Okay, so in summary, I mean the data center is requiring more high I/O applications for all the reasons I outlined, the reasons Kevin mentioned, and SAS is a viable technical alternative. It has moved ahead in technology. It addressed some of the shortcomings. It says higher performance, but it's lower cost. Okay. So I think that's really all my prepared remarks. We've got just a few minutes left for some questions.
Certainly in one sector, people are using InfiniBand. I wondered if you've done any comparisons or what you could comment about InfiniBand.
We didn't, the question was, did we, or have we considered InfiniBand? We did not include it in our testing at the time because we felt it was outside the scope of our original concept, which was SMB space. We think the latency result would be the same. We think the cost result would be the same. We'd have to do some more work to talk about the other parameters.
Okay. Hi, this question is for Larry.
Yes.
AOSI just announced the acquisition to the SandForce. So would you like to give some comments on the acquisition? What does this mean to the two companies? What does this mean to the SSD industry?
So we believe that flash technology is an important aspect of storage technology. that, as evidenced here, the data center needs. It's a part of the solution going forward, and LSI wants to participate in that. LSI is very vertically integrated already in storage. We build, you may not know, disk drive preamplifiers, ASICs for HBAs, RAID controllers, and all our board level products based on those ASICs. And up until recently, we also did systems solutions, which we've sold to NetApp a few months ago. Flash being very important. It's pretty obvious that this is offering to buy SandForce. That's concluded, will be concluded in the first quarter of next year, is a attempt to sort of emulate that same strategy, becoming vertically integrated in a storage technology that will enable us to offer leading board level products. I think that's probably I didn't get prompted by the executives, but they'd say something pretty close to that.
This is another question for Larry. Most of these other technologies you're comparing to have some type of checksumming or something to make sure the data stays intact. Does SAS have anything like that?
In current SAS 2.1, the answer is nothing in the standard. Many products feature that capability. There's a thing called end-to-end protection. It's a standard being developed in T10. We suspect it will be part of 12 gig SAS as a standard. But many products have it now, and you sort of have to shop around to get that. Obviously, if you want end-to-end protection, then you have to make sure all the products have it. Yes. Yeah. LSI has products with support T10.
Real quick, we have time. One last question.
When chatting with people about SAS through the conference, one comment was about, that there are the 4-channel paths there, but I guess I don't know if it's a software thing. Those channels aren't actively used, or can you comment about how do those 4 paths get actually leveraged?
Okay, very good. There are several levels of that. The first level is that you're absolutely correct. That's called the SFF 8088 connectors, the standard connector. There are 4 full duplex paths involved in that connector. If and the rest of your question, I think, has to do with actually a software question. If those 4 hardware paths are addressed by one port address, then we refer to that as a wide port. Okay, and then it's a 24 gigabit SAS port, and the technology shares the bandwidth, puts it across those the different physical paths as chosen by the technology. Right. It gets very complicated when downstream devices have other generations of SAS or SAT, about how the bandwidth is maintained through that. That takes a whole nother discussion. But the key element is whether it's a port or a wide port, and I would use that as the distinction. So wide port is 24 gigabits. And watch out for the legacy things.
A little short on time, guys. Great presentation. Thank you very much. Thank you, Kevin, Larry.